are so many chemical equations. Isn't it hard to remember these chemical equations? Hello students, welcome to Learn Guru classes. So today we'll be discussing about types of chemical reactions under the first chapter of class 10 science, chemical reactions and equations. So in this video we are going to study about different types of chemical reactions, and I assure you that after watching this video you will be able to predict the products based on seeing the reactants, as well as you don't need to memorize chemical reactions anymore. So with this note, let's start our class. We all know that in a chemical reaction, the reactants combine together to form new substance that we call it as product. Now, based on the reactant, the products are formed. So, based on the number of reactants to give rise to new products, chemical reactions are basically categorized into 5 types. So, the first one is combination reaction. Then comes decomposition reaction. Third one is displacement reaction. Fourth one is double displacement reaction. And the fifth, the last one, is called as redox reactions. So let's learn them one by one. So let's start with the first type of chemical reaction, that is combination reaction. So before that, what is the literary meaning of combination? Combination means joining or mixing of two or more things together. So we can define a combination reaction as when two reactants combine to give rise to a single product. Okay, so let's try to visualize this in the form of some graphical representation. So here the blue square represents the reactant A, the red square represents reactant B. So both A and B combines or reacts together to give rise to a single product C. So let's look into some examples of combination reaction where hydrogen and oxygen combines together to form water. So the chemical equation is H2 plus O2 gives H2O. Now here hydrogen and oxygen are the two reactants. So both of them react together to give rise to a new product, that is water. So the water is a single product. Now let's try to visualize this in the form of graphical representation where the red square represents hydrogen molecule, the blue square represents oxygen molecule, and both of them combine together to form water molecule. So the equation here is not balanced though. So the balanced equation is 2H2 plus O2 gives 2H2O. Let's look into some other examples of combination reaction. So the first one is when calcium oxide reacts vigorously with water, it produces calcium hydroxide, that is called as slaked lime, along with liberation of heat. The chemical equation is CaO, that is calcium oxide, plus water gives us calcium hydroxide, that is CaOH2, along with release of heat. Another example of combination reaction is when burning of coal, that is carbon plus oxygen gives rise to carbon dioxide gas. So here also we see that two reactants are used and it gives a single product, that is carbon dioxide. Another example, sodium Na plus Cl2 gives NaCl, though it is not the balanced equation. So the balanced equation is 2Na plus Cl2 gives 2NaCl. The second type of chemical reaction is decomposition. So do you know the meaning of decomposition? Decomposition means breaking a single substance into many other smaller substances. Okay, so basically in a decomposition reaction, a single reactant breaks down into many two or more products. Okay, so basically it is just the opposite of combination reaction. In a combination reaction, two or more reactants combines to form a single product, and in a decomposition reaction, a single reactant decomposes or breaks down into many products. So let's try to analyze this in the way of graphical representation, where a reactant AB is present. So AB exists in the form of a red and yellow box or square joined together. Now when it reacts in the presence of sunlight or heat or any other agent, it breaks down into two products, that is A and B. A is represented as the red square or block and B is represented as the yellow square or block. One example of decomposition reaction is when calcium carbonate is exposed to heat, it breaks down into calcium oxide and carbon dioxide. So the chemical reaction is calcium oxide, that is CaCO3, in the presence of heat breaks down into calcium oxide CaO plus carbon dioxide gas. Now if we try to analyze this graphically, CaCO3 is the reactant used over here, and in the presence of heat breaks down into two separate boxes, that is red box and the yellow box. So the red box represents calcium oxide and yellow box represents carbon dioxide. Some other examples of decomposition reactions are lead nitrate in the presence of heat decomposes to lead oxide, nitrogen dioxide and oxygen gas. Silver chloride in the presence of sunlight decomposes to give silver and chlorine gas. Silver bromide in the presence of sunlight decomposes to give silver as well as bromine gas. So basically this is used in black and white photography. Now another practical example of decomposition reaction is the digestive system of human being, where we eat many complex food and this decomposes or breaks down into simpler substances which we call it as nutrients. If you have gone through all the decomposition reactions carefully, you see that the reactants break or decomposes under the presence of some energy. Like it may be either heat energy or light energy, that is sunlight. So basically energy is required to decompose the reactants into products. So this type of reactions we call it as endothermic reactions. The third type of chemical reaction is displacement reaction. So the literary meaning of displacement is moving something from its original position. Here one reactant exists as AB and a second reactant called as C is used. So when these two reactants react, they give rise to AC plus B. That is, you see that B has been shifted from its original position and C has taken place of B. That is, C has displaced B from its original position. Okay, so this is the beauty of displacement reaction. Now, which element will displace which element? So that is basically dependent. The element that is more active, that will displace the less active element. we can determine the element which is more active or less active by the activity series of metal given over here. Some examples of single displacement reactions are, first example is iron reacts with copper sulfate to produce iron sulfate and copper. So since according to the activity series of metals, iron is more active than copper. So iron displaces copper and forms iron sulfate, leaving behind copper. Now let's try to analyze this in the form of some graphical representation where the red and the green box joined together exists as copper sulfate and iron exists as the blue box. Now when it reacts, it forms a new compound, that is iron sulfate, that is it is the red and the blue box that is called as iron sulfate, leaving behind the green box that is copper. So here if you see why it is called a single displacement reaction, because only a single element has been displaced. So hence it is called a single displacement reaction. Zinc reacts with copper sulfate to form zinc sulfate and copper. So here zinc displaces copper from copper sulfate because zinc is more active than copper. Another example is lead reacts with copper chloride to form lead chloride plus copper. So here lead being more active than that of copper displaces copper and form lead chloride along with copper. The fourth type of chemical reaction is double displacement reaction. So what is double displacement reaction? In a double displacement reaction, two compounds react to form two new compounds simply by exchange of ions. Now how does this occur? So let's try to visualize this in the form of our graphical representation. So here AB is a compound, that is a reactant, and CD is another compound. So both of them, if you see, reacts together to form AD and BC. Now how this occurs? Now if you see a simple product AB. So the general form of representation, let's take another one compound NaCl. So NaCl basically exists in the form of AB. Now when NaCl forms a bond, that is ionic bond, what happens? Na, that is sodium, releases one electron to form Na plus and chlorine accepts that electron to form Cl minus. So basically here also AB can be represented in the ionic form as A plus B minus. That is A is a metal, B is a non-metal. So hence A plus B minus. Similarly CD also exists as C plus D minus. Now when the compound will be formed, what happens basically? A plus will react with D minus to form a compound, that is AD, and B minus will react with C plus to form a compound, that is CB. Okay, so here what you see, why it is called a double displacement reaction? Because A comes with D, this is one displacement, and B comes with C, this is another displacement. So henceforth it is called a double displacement reaction. One example of double displacement reaction is when sodium sulfate reacts with barium chloride, it forms sodium chloride and barium sulfate. So Na2SO4 plus BaCl2 gives 2NaCl plus BaSO4. Now what happens here? Sodium reacts comes with chloride and barium comes with sulfur. So hence it is double displacement reaction. So the ionic representation of NaSO4 is Na2SO4 is Na plus SO4 2 minus, BaCl2 is Ba2 plus Cl minus. So what happens here? NaCl comes together to give rise to 2NaCl plus BaSO4. So obviously this is the balanced equation. Now if we look into the graphical representation, we see that Na2SO4 is the block and barium chloride is another block. So basically exchange takes place and hence it forms NaCl and BaSO4. Let's study the fifth and the last type of chemical reaction, that is redox reaction. So before studying redox reaction, you should know from where the word redox originates. So redox has been broken into RED, that is it stands for reduction, and OX, that is it stands for oxidation. Now what is oxidation? What is reduction? Let's try to understand this before going into redox reactions. Let's look into oxidation reaction. So by the name oxidation, what do you mean? Something is related to oxygen. So oxidation reaction can be defined in many ways. So the first way is addition of oxygen is called as oxidation reaction. Second is addition of any electronegative element is also defined as oxidation, or in other words, removal of hydrogen or removal of any electronegative element or electropositive element is also termed as oxidation. So let's look into some examples of oxidation reaction. The first example of oxidation reaction is when carbon reacts with oxygen, that is C plus O2 gives carbon dioxide. So it is an example of oxidation reaction. Why? Because oxygen is being added to carbon and carbon dioxide is formed, that is carbon is being oxidized due to the addition of oxygen. Another example of oxidation is iron plus sulfur gives iron sulfide, that is FeS. So we all know that sulfur is an electronegative element. So when sulfur is being added to iron, what happens? Iron is being oxidized. Okay. The third example is H2S plus Cl2 gives 2HCl plus S. So over here what happens? Hydrogen has been removed from sulfur. Okay, so since removal of hydrogen occurs here, we can say that sulfur is being oxidized over here. Now let's see what is a reduction reaction. So reduction reaction is basically just the opposite of oxidation reaction, where reduction reaction is defined as addition of hydrogen or any other electropositive element is called as reduction, or in other way it can be defined as removal of oxygen or any other electronegative element is also called as reduction. So let's look into some examples of reduction reaction. When nitrogen combines with hydrogen to produce ammonia, that is N2 plus 3H2 gives 2NH3. So basically what happens here, hydrogen is being added to nitrogen, means what? Nitrogen has been reduced due to the addition of hydrogen. Another example is when zinc oxide reacts with carbon, it gives zinc plus carbon monoxide. So over here zinc becomes free of oxygen, means oxygen has been removed. So we can call that zinc has been reduced. So these two are the basic examples of reduction reactions. So by this time, redox reaction is already clear to you. Yes, redox reaction is a type of reaction where both oxidation and reduction reactions takes place simultaneously. So let's look into some examples of redox reaction where copper oxide reacts with hydrogen to form copper plus H2. So over here, oxygen is removed from copper, means what? Copper has been reduced due to the removal of oxygen, and if you see here, hydrogen is being oxidized due to the addition of oxygen. Another example of redox reaction is H2S plus Cl2 gives S plus 2HCl. So over here, sulfur becomes free of hydrogen, means removal of hydrogen occurs. So this is called a reduction reaction. Hydrogen, removal of hydrogen occurs, means it is an example of oxidation reaction. And in chlorine, hydrogen is being added, means it is an example of reduction reaction. So see here, in these reactions both oxidation as well as reduction takes place. So this is all about types of chemical reactions. I hope you have understood the concepts that I have tried to explain to you. So if you like this video, please subscribe to Learn Guru classes, like, comment and share it with your friends and family. So thank you so much. Bye-bye.